Okay, half of that, 1.4. Tired of questions, I can see. Okay, so my name is Stéphane Nicoll. I'm working on the Spring Boot team. I'm also working on Spring Framework. If you've used Spring Boot in the past, you've probably also tried a website called start.spring.io, which allows you to get started. I'm also working on that. So the purpose of this presentation is to see what's coming up with Spring Boot 2. The active development of Spring Boot 2 have barely started. As you'll see in this presentation, the big theme is a new generation for Spring Framework, so Spring Framework 5. We released the release candidate 1 last week, and there is a milestone 1 that was supposed to be out today. We have a few, let's say, unexpected delay, so it's going to be out on Wednesday. So you'll be able to use it if you want to give that a try. So I'm not going to focus a lot on individual features. I'm just my plan here is more to give you a feeling of what Spring Framework 5 brings and how you'll be able to use it in Spring Boot. And if you haven't used Spring Boot already, then it will give you a feeling what the development experience looks like. And if you are using it already, my plan is to show you that those new features will seamlessly integrate with your infrastructure, so you don't have to learn a new thing all over again. So what's coming in Spring Boot 2? So as I said, we're still in active development with milestone 1 to be released. We plan to go GA by November, so there's still quite a lot of months to go and quite a lot of features that we need to integrate. So one thing is, if you are using Spring Boot, you know that we have a great story for dependency management. So basically, you don't have to care about the individual versions of open source components that you are using. So if you are using Hibernate, we will bring you a compatible version. If you are using MongoDB, Neo4j, Redis, if you are using Tomcat, Undertow, Jetty, etc., etc. So this whole ecosystem that Spring Boot integrates with, we provide a dependency management for it. And of course, the idea is that all those together work together. So we make sure that's the case. So once you'll upgrade to Spring Boot 2 or you start using Spring Boot 2, there is a bunch of dependencies that will be upgraded in the process. So you'll get, for instance, Hibernate 5.2 as the default. We've been quite conservative in the 1.5 release line. So finally, we go with the latest 5.2 in Spring Boot 2. And a bunch of other dependencies will also be upgraded. And of course, we'll provide consistent auto-configuration for it. We'll also get a chance to review some of the decisions that we've made. So if you use Spring Framework, you know that even if you go to a next major generation, you don't have to rewrite all your code, and basically an upgrade, at least for the framework functionalities, do not break we do not break API unless we really have to. That's because the framework is really generic and allows you to compose bits and pieces together, whereas Spring Boot gives you a default experience. So if you don't have any opinion, we'll have an opinion for you. We'll have a sensible opinion for you. And sometimes we were wrong in those opinions. And we learn from the feedback of the community that things could have been done differently. So Spring Boot 2 is a chance for us to revisit those decisions. So for instance, if you are using Spring Boot and the Gradle plugin, you know that things aren't perfect compared to other plugins. You don't get the extension points that you'd like, and there are things that are not really working the same way as for other Gradle plugins. We learned that the hard way, and we've decided to rewrite the Gradle plugin in Spring Boot 2. So if you have some issues in the 1.x line, I'm sure those issues will be resolved. We are also completely rewriting the configuration properties binding stuff. So the way we bind your configuration to the environment. That's because the way we did this wasn't really easy to understand. For instance, if you want to override a list of properties, it wasn't really easy to know if you are going to override an individual element, override the whole list, or you could merge different opinions if you have different profiles with different values for a list. So those two are going to ship with M1, and there are more to come. But the biggest topic of Spring Boot 2 is Spring Framework 5, and that's pretty much the rest of the presentation today. So Spring Framework 5. What do you get with this new generation of the framework? First thing is performance improvements. So we are in a situation today where more and more you're using an Elastic engine, or you're using multiple services. So if you have more traffic, usually you have an infrastructure that will start a new instance for you automatically to handle the load. And once that traffic is gone, that load will shut down to save your bill, basically. So it's very important in that kind of infrastructure that your new service, your new instance of the service starts as soon as possible, as fast as possible. So we've been revisiting what happens when the application starts. So basically, in Springland, that's called the application context. So when the application context creates beans, find components, start them up, etc., how can we fasten that process? And one thing that quickly was identified as maybe a point to investigate was class path scanning. So class path scanning is the process that finds candidate components. So you give it a package space, and it will basically scan a class path in that package space to find components, and it will create beans automatically for you. And there is this idea in the community that class path scanning is slow. So who thinks that class path scanning is slow, for those who have used that in the past? Yeah, I can see 1 and 2. Okay. So we thought that maybe we could have a look to that. And what we've done in Spring Framework 5 is we've built an alternative to it, where we will identify our components at compilation time, and we will generate a file with the components. And that file will ship in your jar file. And when you start the application, we will look at that file that we've generated at compilation time, and we won't scan the class path again. Turns out that this doesn't really save you much, because class path scanning is already quite fast. We've done a bunch of benchmarks to prove that. So it's still very interesting if you have a lot of classes. So for instance, if you have a project with 50,000 classes, it might be interesting, but maybe you have a different problem. And in the end, that wasn't totally useless, because in the process of building that feature, we've noticed that we could have improve things in certain areas. So if you upgrade to Spring Framework 5, class path scanning will be faster, but it wasn't that slow before. The next big feature is Reactive Spring. So who knows about Reactive already? I usually get 20%. That's more 10%. Okay. So we'll see that in a minute, what Reactive Spring means. But it's basically a new way for you to build your applications in a non-blocking, event-based way. Okay. So we'll see that, and we'll have a few demos in the rest of the presentation. As you'll see, using reactive programming, so basically building your web apps typically to be asynchronous and non-blocking, you have to do it in a certain way that remembers functional programming. You'll see that in the examples if you don't know about that. So what we thought in Spring Framework 5 is how we can extend that feature to other areas of the framework. So how can you, for instance, build your application context programmatically? Or can you avoid the use of annotations? We had that topic recently at this conference. So how can you build a Spring application without annotations? So that's some of the things I'm going to show you. And to the extent of that is, if you decide to go that way, again it's about options. It's not like you have to do non-blocking functional. All of a sudden, if you upgrade to Spring Framework 5, all the things that you are using today will still be perfectly valid and supported as a first class of citizen in 5. But if you decide to go that route, maybe you're frustrated with what Java brings. So maybe you're looking for a different programming language that could help you design your functional-based application. And Kotlin is the new kid on the block, you'll see. And we've built first-class support for it in the framework. So I will show you that in a few demos. So let's go with Reactive Spring. So for the 90% of you that don't know what it is, it's going to be a gentle introduction. My aim here is not to, because I'm not educated enough anyway, my aim is not to give you a full overview of Reactive, but to give you a feeling of what it is and when it's useful. Typical application today. So what do you have? The server is the thing that you are building is in the middle there. What you have, one, you have super fast connections with super fast machine, so you want to give them the best experience. Whenever something is available, you want that to be displayed on the screen. You don't want them to reload anything. Everything appears as it comes, so you're using server sent event or WebSocket to do that. And in a traditional world, well, you need server resources to handle that. Then more and more, what you'll get is plenty of clients on mobile device, and potentially those clients are on a very crappy network. So you have lots of clients that are trying to contact your service, and of course, when they can't, what do? They hit the refresh button, and that's another request that you have to handle. Your service, more and more, has to also contact other services. So it has to, we are more and more distributed in the way we build applications today. So that server that you are building needs also to contact other services to get data. And sometimes it can be slow, or there's some latency, or that service does not behave properly. And if you combine all of that, your server is basically going like this. So reactive programming is a way for you to handle those situations. So it's really not about speed, pure speed. Look, so the fact that going event-based asynchronous non-blocking is not for speed, but it's for scalability and stability of your system. So if you have a lot of new requests coming in, your server doesn't die. So it's better, it reacts better to the load, and we'll see why in the rest of the presentation. So quickly, just to show you the two paradigms so that you can relate to what reactive is compared to what you know today. So what you know today is if you build a web application, be it with Spring or something else, in Java at least, you have the servlet API. On top of the servlet API, you have a servlet container, and that servlet container has a thread pool. And basically, for each incoming request, you allocate, well, not you, the servlet container does, a thread to the request. And the thread is basically processing everything about that incoming request. So reading the bytes from the client, even if the network is slow, and you basically have to wait because the network is crappy. Process the business logic, so that's the code you write, including calling other services. So if you have to call other services, you basically have to fork, use a thread pool of your own. Join if you have multiple invocations, well, you know all that, it's a mess. And once you've computed the result of the query, you have to write it to the output stream. And again, if the network is slow, you'll have to wait. So this is what you do today. And blocking is by no means something negative. It's not going away. It's perfectly fine for plenty of applications. So it's not like reactive is going to fix all your problems. It won't. If you look at what happens in a reactive-based application, a non-blocking application, you don't get a thread per request anymore. You basically benefit from the capacity of your server. So if your server is able to process 8 threads in parallel, so natively, so not by context switching, but natively it can do 8 things in parallel, you'll get 7 worker threads. And those 7 worker threads, so 8 minus 1, those 7 worker threads will basically get bits and pieces for any requests. So a request will not be attached to a thread, but a request will be made of events and operators. It will be defined as a pipeline of things to do, and those things to do will be performed when there is a resource available or when the data has come. The other thread is a thread for the reactive library implementation, which is basically dispatching the data, dispatching the load, dispatching the things to do. So you're basically using all the power of your server, and you're not having like 500 threads for 8 threads you can run in parallel and context switching them all the time, because each thread has a memory allocation, and switching the context takes also a lot of CPU, especially on high load. So the idea here is to restrict to what the server can do and to dispatch in a smart way. So basically you become neutral to latency. You're not waiting anymore, so the fact that something is slow does not impact you. Of course, the overall response time, if the service behind is very slow, will also be slow. It will not be faster all of a sudden. But you won't have a resource waiting for it anymore. So let's have a look into code, finally. If we look at what you know today, what I call imperative style, but something that you'll use in a regular application today, you have a repo. You can see that down on the slides there, where the repo returns a person, and if that data store, so be it, let's say it's whatever data store that's slow at the moment, if that data store can't give you that information right away, the thread will block. So the first line, the thread will block until the person is there. Once you have the person, then you can run whatever business logic you have, and if something happens, you put a try-catch and everything is fine. That's what we do. If you compare that to a reactive approach, you'll see that the return type of the repository have changed. So they don't return a person. They return what we call a publisher of a person. So they return something that will give you the data when it's there. You can see 2 types there. We are going to go back to that, but for the moment, just see mono and flux as publishers. So you no longer have a blocking one-by-one operations in a reactive paradigm, but you are defining a pipeline. So you basically retrieve a publisher that will give you the person with that ID. Once you have that, you use the map operator, which allows you to take an element and apply some logic to it. And nothing will happen until your pipeline actually starts. And the way it works in the reactive world is by calling subscribe. You may be a bit scary at this point, especially translating that to the previous slide. Do I have to call subscribe myself? What happens when I do? Where do I need to do this? So the answer is that you don't do that. You don't call subscribe, you don't implement publisher. You have an infrastructure, you have a framework that does that for you. And that's what I'm going to show you in the demo. There is no, it makes no sense to have a reactive application with the benefit that I just explained and have some kind of blocking code in between. So you need to be non-blocking end-to-end. It means that the thing that reads the data, the HTTP request from the input stream needs to be reactive. Your code needs to be reactive. The component that you use to get the data from the data stores needs to be reactive. And the thing that writes the output to the client needs to be reactive. If you have a blocking code in between, remember you only have 7 threads on an 8-core machine, processing stuff from every request of your server. If you have blocking code, you know what happens if 7 of them are actually running concurrently. You don't do anything else anymore until that's done. So to be able to, for those different components to communicate, if you're using a MongoDB store, for instance, you'll have a MongoDB driver. If you want to write something on the socket, you'll have some component in Spring Framework that does that. But those need to communicate. They don't know each other, so they need some kind of API. And that API is called reactive streams. And reactive streams can be seen as a publisher and a subscriber, very easy. The publisher is you get a publisher instance that represents data that you're interested in. And the subscriber said, okay, I'm interested by that data. Once you have that data, I want to do something with it. So I'm subscribing to it. The key here is the subscriber is actually asking for data. So if the publisher has 1 million elements and the load of the server currently does not allow me to process those million elements, I don't want them to come. I'm asking for them. And if the load of the server increases at some point, maybe I'll ask less, and the other way around if my server isn't busy. Again, that's not something you do. An implementation of reactive stream, so that's the IO selector thread on my previous slide. That's the component that will, based on the load of the server, do what's smart. So you request a number of elements. That's the concept of back pressure. So the subscriber is telling, I want 20 elements, I want 100 elements, I want 2 elements, based on his load. So you'll get on next with some data. And such publisher may be infinite. So for instance, if it's live data, livestock data, it never ends. But if you search for every user with a given last name, probably the data is finite. So you'll get a completion signal, or you'll get an error signal. So the error signal is the try-catch that you had before. You basically need to do something. If there is an error, you need to do something about it. Reactive Streams is a very complex API, as you can see. There are 4 components in it, that's it. And quite an extensive TCK, so to be able to pass the TCK, there is a lot of things that you have to, a lot of tests that you have to pass. And there are plenty of Reactive Streams implementation you can choose. The one that we use in Spring Framework 9 is called Project Reactor. But you are free to choose a different one. So there is Eric's Java 2, EK Streams, and others. So we were discussing about this mono and flux stuff. And you probably guessed from the return type and what they were returning that there is some concept of cardinality involved. And indeed there is. Mono returns 0 or 1 person. Flux returns a stream of persons. If you look at the code there, just to share a story, we don't know how many meetings we had to find those names. So when you look at Flux, it feels a bit funky at first. But there were 2 things that we had to come up with. That's the reason why we don't know how many meetings we spent on this. One is needs to be short, so that doesn't add too much noise to your code. And 2, it must have the same length so that your code is indented properly. So if you think that Flux is a lousy name, then think how many hours we spend finding those names. Okay, so Flux. Quickly also, if we go back to here on the publisher, you see that the only thing I get is subscribe. And you've seen on this slide, actually on the publisher, I'm calling map. That's because the implementation of reactive streams will give you operators. It will give you high-level functions to actually map the process the data, sorry. And Flux will have dedicated operations for Flux, for stream, sorry, and Mono will have dedicated method for unitary element. I basically said that. So Flux, you have a bunch of data coming in, you apply an operator, and you'll get something else, or an error, or a complete signal. And Mono, you get 1 or 0. So if you get 0, you basically have only a complete signal. That's the save there. You've seen mono of void. That's basically a signal to mention that the save completed successfully, and then you can do something else after. Demo time. So you usually don't, well, there are very specific reasons for you to choose reactive. So if you, for instance, if you serve data, as a REST endpoint and you don't have millions of data or millions of clients, there is no way to switch to this. But if you have a high number of concurrent users hitting your servers, you need to reach out to other servers, you need to combine data from multiple services. So there is a reason to choose that technology. What I want to do with the demo is not to show you first a typical reactive demo. I want to show you something that you would build with servlet and blocking. The servlet and the blocking model to show you what the getting started experience is. So if you are using Spring Boot, you'll see the difference, and there are many differences. If you don't know about Spring Boot, it will give you an idea of what it is. So one way is using this website, start.spring.io. I'm choosing a Spring Boot 2. As I've said, the reactive support is on Spring Boot 2. Then I can add a bunch of dependencies. So for instance, I'm going to use a web application in MongoDB, and I'm going to create a project. And that's going to create me a project here, an empty project that I can use. Or I could do that directly from the IDE. So same thing, it's the same service. If you are using NetBeans or Eclipse, they have also a plugin for that. So let's see, Reactive Web and Mongo. That's the one. Okay. So let's call that Relia. So what I want to do is really something very not super. I mean, it's not the most interesting demo you'll ever find, but what I want to show you is the getting started. So how can you actually build a reactive endpoint that's not non-blocking end-to-end. So I'm going to show some data, and I have some data here somewhere. Here we go. So nothing reactive about that. It's a MongoDB document for a speaker. Now what I want to do is add a repository for it. And I want this repository to be reactive. Remember, it needs to be non-blocking end-to-end. So I'm going to say I want a CRUD repository for a speaker. And I'm giving the primary key of the object. Then I'm going to say I want to return a speaker with a given Twitter account. So Spring Data is the component in Springland that will take care of that for you. But because it's reactive, you can't return a speaker, right? Because that's a blocking operation. You want to return a publisher of speaker. So the only thing that changes besides the type here, which is reactive instead of CRUD repository, if you've used Spring Data in the past. The only thing that changes here is the return type, and we will adapt to that return type. We'll know about that return type and do the right thing. Same thing if I want to create a web endpoint for this. So I'm going to create a new class, would be better. So I'm going to inject my repository. Nothing really complicated about that. And I'm going to show all the speakers. So again, if you want to be reactive, you need to provide a publisher for it. Something like that, right? And I need to flag my controller. So if I start this app, if you've used Spring Boot in the past, it's typically an app that you could have built. I have nothing because my data is empty. Good point. So I cheated. I have a speakers database on my system with some data in it. Here we go. Here we go. So, like I said, from the feature that I've built are not very exciting. What's more exciting is this is non-blocking asynchronous end-to-end. So including reading the data coming from the client, calling the services behind the scene. It's using the Reactive Streams MongoDB driver. And once we get the data, we write that to the output stream in a reactive way as well. As you've seen, I'm not calling subscribe, I'm not calling request, I'm not calling any of those because the framework is taking care of that for me. I could also write this, and two I want to give more details about two of them. The first one, get by ID. What happens if the user doesn't exist? I want to return a 404. How do I do that? Well, when you're working with a reactive application, you're basically chaining events and chaining things. What should happen if? So you have the switch if empty operator, which allows you to run some logic if the publisher that you have basically doesn't have any data in it. The other one is the last one on the save. You can see that the request body is also taking a mono of user. What that means is we will not bother to actually read the content of the request body until actually someone is requesting it. So typically in this case, because the code is very simple, in this case, when the, let's say it's MongoDB, when the MongoDB driver is going to ask for the data, so it's going to call request on the data, because it's now able to actually save the user. At that time, we will read the data. There is also a new web client API that you can use both with a reactive application, of course, or in your existing application if you want to. There's really there's no hard requirements to be a reactive end-to-end to use this. As you may guess, this is doing composition and join with very elegant code, so you don't have to use thread pools, you don't have to create a thread, put the first HTTP GET in the first thread, add the second HTTP GET on the second thread, then do a join, and if there is an exception, have some kind of code of yours to send back an exception. All you do is you define your pipeline, so you create a mono that basically a publisher of GitHub user and a publisher of Twitter user. That code is not going to do anything. You're basically describing what should happen. Then you combine them with the AND operator, and the AND operator is a way to combine two mono and one combine two data. And once you have that, you'll get a callback. So this chain that you build with the web client, everything that's related to latency, we will handle that for you. So summary of what you have today in Spring Framework 4, the current production generation. You have your servlet containers, the servlet API, a component to build web application that's called Spring MVC, for those who don't know about it, and a programming model that I've shown in the demo. So controller, REST controller, the get mapping thing that was in my demo is actually the same thing as request mapping. So this is what you have today. What we offer in Spring Boot 2 with Spring Framework 5 is a new option. So it's not one that replaces the other. It's a new option that you can use if you decide to do so, if you think that's useful. If you're fine with the blocking model and the servlet API model, so the current Spring MVC model, that's perfectly fine as well. And we've built that on top of many containers. So for instance, this demo is running on Netty. There were many users actually asking us for support of Netty, and we couldn't do that because they don't have a servlet API. Now that we don't have this constraint anymore, at least for reactive applications, you can deploy your apps on Netty, or you can also deploy your apps with native on the toe, or you can also deploy your apps on a servlet container, because we have an adapter for that. And the companion of Spring MVC is called Spring Web Flux. Remembers you the Flux name. So that's the name of the component that's dealing the reactive part in Spring. You can use that with the annotation model, as I've shown you. But if you decide to do it differently, so if you want to push the concept of functional programming a bit further, we're also offering you now a new way to build your router and your MVC routes, and that's called router functions. I want to show you that. So I've told you already about functional APIs and pushing that a bit further than what we have with Reactive. So for instance, this is something that we are currently working on. It's probably going to, you already have part of it in 5.0, and we'll keep on working on it in 5.1 and 5.2. So it's a way to build your application context programmatically. So not using configuration, add bean, component scan. You basically define your infrastructure and how to build it. And we will build a context with that kind of API. If you don't want to build your controller using annotations, so using the @controller and @request mapping, like in my demo, you can create a router programmatically. So that router is pretty much doing the same thing as the slide I've shown you after my demo. So one route to get all the users, one to get the users by ID, and one to save a user. And the body of, well, the callback you get for each predicate is a function that takes a server request and returns a server response. So it's a new API. Of course, you can use Java 8 method reference to just move those into separate methods, and basically you can write your router like this, which is much more readable. So this is really an alternative if you want to use that. Who knows about Kotlin? Okay, that's 40% maybe. Okay, so Kotlin is a language that a company called JetBrains is sponsoring. JetBrains, the guys who run plenty of development tools, including IntelliJ IDE. And Kotlin has many interesting features that we could even improve further in the framework. So I want to show you some of them. The first thing that's nice about Kotlin and that we use internally is extensions. So extensions is a way for you to make Kotlin smarter about your API. So in this case, you see that the body method takes a publisher, that's the repo find all thing, and a type, that's basically the type of the body. And we know already what the type is, because find all is returning a flux of user. So we know that. But Kotlin as a compiler doesn't. So you can write an extensions that basically helps, that basically teaches Kotlin how to be smarter about your own API. This is something that you have to import in your own code. So the purpose here is to remove the user class.java thing. Actually, I think the story is Kotlin fans, they think that if you put a type as a parameter, it's really something you should never do. So they managed to make that very ugly to write. So if you import that, basically that's where we export publisher of T is the same thing as publisher and T class. We basically extract the type from the first parameter. You can omit the second parameter, and because you don't have that thing, you can also inline the method declaration. New label information, we've also discussed for those who were in the room for the previous session, we've discussed about null handling. Kotlin has actually a very good story about that. Everything that might be null in Kotlin needs to be flagged, so you need to put a question mark after the type. And Kotlin is smart to basically see if there might be a null pointer exception and give you a compilation error rather than you having a null pointer exception at runtime. We have the same concept in MVC world, so with the request param here. So if you do foo question mark, bar equals something, it's going to inject something in the bar parameter there. But we want the request parameter to be optional. So if you just invoke /foo without the question mark bar, it should work. And that's not the default. The default is you have to provide the request parameter. So if you want it to be optional, you need to add a required equals false attribute on your request mapping method, sorry. So since Kotlin has this information already with the question mark, the thing is that we are actually reading it. So if you define your code that way in Kotlin, because there is a question mark, we know the parameter is optional, and we know that the request attribute is also optional. Custom DSL. So this is a way to, you've seen a way to define your router in the previous slide. This is Java, by the way, not Kotlin. There's too many parentheses for that. So this is how you would build that with Java. It's quite messy, let's say. But you can write custom DSL with Kotlin, and that's basically how you can write it in Kotlin, which is much more readable. You can, of course, do that with your own code if you want, but the point I'm trying to make here is that we do that for you for the Spring APIs. If you're interested by Kotlin, and especially how it works with Spring Framework, there is this article which is quite interesting. It explains some of the things I've shown you, and much more in many more details. Okay, time for 5 minutes for a different demo. So I want to go a bit further and show you, I say not really more complex stuff, but things where there's a bit more meat to it. So I have an app. It's running on Spring Boot 2 Snapshot, and it's using TimeLeaf as the template engine. I'm supposed to show a list of developers. So if you've used TimeLeaf, you know that there is a model. You need to put things in the model. So if we look at the If we look at the template, there is a user parameter there. I'm going to loop over that and fill in the table. Okay? So I need to pass the collection of users. That's what I should do. How do you do that in Spring MVC? Well, you inject a model for your action. And on the model, you add an attribute called users, I think. Need to check back again, I always forgot. Yes. Users, and then you need to put the collection of users there. But you are in a reactive-based application. So you can't be blocking. You need to pass a publisher of users and not the users. And basically, if you write this, let's see if it works. So if you pass the publisher in the model, basically, we will handle that for you. And render the view in a reactive way. So we have support for TimeLeaf. TimeLeaf has a great story on Reactive, by the way, if you look at TimeLeaf 3. Mustache also is a supported template engine. And we might have others, I'm sure. Then I have a different demo here. I have a service running on this machine on a different port. So on port 8080, there is a quotes endpoint. And that quotes endpoint is basically streaming JSON. I will share the link to those demos after. So if you want to look at what they do and how you can run them on your own machine, it's very easy. So that simple endpoint is showing what happens when you get stock values update for certain stocks like Google and others. So that endpoint is designed to send every 200 milliseconds a new random value. So just simulating what live data could be. Let's say that this service is running on some server, not on my machine. And I want to show a graph of the data live. So I want to, whenever there is a new value, I want to display an update in that graph. Currently, the graph doesn't do anything, and the reason why the graph doesn't do anything is because there is a function that's supposed to do it, but the function isn't called. So what I want to do is I want to create a new endpoint on my server. So this server at /quotes/feed. And what I want to do is I want to return server sent event. And I want to bridge basically the remote service running on port 8081 to my client. And I want to do that in a reactive fashion, of course. So let's do that. Okay, so what do I want to do? Get mapping, quotes, feed, right? I want to return a stream of code. So the JSON that you've seen here, I basically have a value object for it. Quotes feed. So now I want to contact this remote service and basically bridge the two. So let's create a web client. For the service I have. Okay, so I need to contact /quotes. I need to accept JSON stream, and by the way, I'm producing server sent event. Text, yep, that's it. Now I basically need to say every time I get an object from that stream of JSON value, I want to send a server sent event object. So I want to map basically the content of that request to a flux, giving it the type. And that should be okay, like this. But I want to do more. I want to do two things. I want to log. That's an operator that will show me what my reactor pipeline is doing. And I want to share. And share is very important. So if you have 10, 20, 100 browser windows actually calling your service, you don't want to create 100 clients. This is live data. So you want one client and multicasting the data to all your browser actually getting the data. So share is an operator in Reactor that will allow you to share that publisher, share that flux. So I have a client contacting my remote service, getting a JSON stream, mapping that to a Flux, and it's exposing the data at /quote/feed. If I'm looking at my client side, I have an event source on /quote/feed, and every time I get a message, I'm calling the append stock data, and that's the thing on the client side that's supposed to update the graph. So let's see what that does. So that's the kind of feature you can build. You can see the data flowing down there. That's the stream from the endpoint I just created. And that's actually giving you data from the remote service. Okay, so that's the kind of use case you can implement. And if I close my browser windows, I can see that there is a cancel event that's being sent, so basically shutting down the stream automatically for me. If I'm the last one actually asking for it, of course. I'm already almost out of time, so quickly, if you want to get started with this today, you can go and start.spring.io, select 2.0 snapshot. By the time you probably will have a 2.0 M1. If you type reactive in the search box, you'll see that there are a bunch of things that we already support, and we intend to add more. So M1, like I said this week, Spring Framework 5.0 GA June, and we hope to have a 2.0 GA around November. Thank you very much for your attention. Questions? Yes.
Hi. My question is, how are you going to adopt Java 9 modules in Spring Boot?
How do I what?
How are you going to adopt Java 9 modules?
Ha! It's funny, because I didn't talk about that. Okay, good. So Jigsaw and module system. So Spring Framework 5, we have, well, your question is about Spring Boot, so it's even more interesting. If we are only focusing on Spring Framework 5 and the way the application context is built, class path scanning, etc., we have a support for Jigsaw that's working fine for us. It's working fine for us because there is a concept in Jigsaw called automatic modules. So if you have a module that does not provide any metadata, any module info, it's basically considered as, well, I wouldn't say deprecated, but it's more legacy in the sense of the module system, and it can have access to every module on the module path. That's what we use. It's working fine. As for the metadata that we will put ourselves in Spring Framework, we need all our downstream dependencies to provide one first. So all the things that we use need to have a metadata for it, and then we'll be able to have metadata for that. And the plan, unfortunately, is more around Spring 6, Spring Framework 6, so the next major release. As for your question about Spring Boot, it's a totally different question and much more complex because of the auto-configuration model, etc., so we have no idea how we are going to do it. Yeah, so definitely. So we are working actively on Java 9 support in Spring Boot at the moment. Spring Framework 5 already has a build on Java 9. So we have a build on Java 8 and a build on Java 9 with all the integration tests passing. Spring Boot is not there yet, so we are working on that, yeah, definitely.
Hello?
Yep. Oh, sorry. Where are you?
Yeah.
Okay, good.
Hello, my question is about how actually reactive approach lives with HTTP protocol. I mean, the request response model. Are you using some long polling, or are you using WebSocket, or what are you using actually?
So the non-blocking approach really starts, the boundary is on your server. But the difference is if you're talking about server-sent event or WebSocket, what you need a thread on the server per client that you have to manage that connection. With a reactive approach, like I've shown in the slide, it's really about your working thread and the IO selector thread. There is an API that you can use on both on the input and the output, can read and can write, which tells you if you can actually do something, if the network is ready. And that's what we use. So the main difference compared to a traditional approach is that you don't have a thread per client anymore. You just have your connections that you have, but you don't have a thread that's polling or actually managing the client state for you. So whenever there is some data, one of those worker threads is going to do something about it.
I see, but anyway, you still like pause connections or somewhere on backend level in order to actually wait for data to be ready, and then you just respond to them.
You don't really, well, what we do is we have events that tell us that we can actually read or write on the data, so we are actually not waiting anything. We have something that's going to tell us, yes, you can write, or yes, you can read.
Okay, thank you.
Actually, probably I can do it without the mic, it's very short. So how does that affect Spring security? Is there any effect, or do the jet work?
So, great question. How does this affect Spring security? That's a really great question. Something I forgot to mention is, I said during the presentation, you need to be reactive end-to-end. So you need to be able basically to use the tools that you use today, in Springland at least, in a reactive fashion. So you'll see alongside Spring Framework 5, all the modules, all the projects in the portfolio will also upgrade to this model. Regarding Spring security, there is one major issue. If you think how the programming model works, so basically your security context is held within a thread local, so in the traditional model. So you have an incoming request, you authenticate, you're logged in as user foo, then all the things that's happening for that thread processing that request will have that information. If you look at a reactive paradigm, you don't have that anymore because the request might be processed in different threads. So what we are working right now, and there is actually a Spring Security 5.0 milestone 1 that was released last week. We are working on a context object that we can attach to a publisher. So we try to implement that differently, but the definitive answer to that is you'll have to upgrade. So you won't be able to use reactive with Spring Security 4, for instance. The back there, probably too far for me.
Wow, thanks. Mike finally reached me. So my question is, like, I remember a few years ago, Pivotal was everywhere saying about SSE, server-side events. So right now, nobody's talking about that. And you guys are starting to talk about reactive, which is understandable. What do you think about gRPC and HTTP2 in context of Spring Boot?
So I don't have an opinion about that because I'm not educated enough in the web space. This is not my surface area, so I'm not going to say nonsense to you. But when you're saying that nobody talks about server-side event anymore, I disagree. I think there are plenty of actors that still talking about it. My demo was about server-side event, by the way, in case you didn't notice. I'm not sure if that's proving any point, but actually there was server-side event in this presentation. But this is a great question. If you're interested, we can maybe reach out after the talk and I can redirect you to the right person that can answer your question. I think I'm done. Enjoy the rest of the conference. Thank you.